All right, welcome back. Now we're going to actually take a look at the code we discussed last time and see this iterator class at work. So let me bring the laptop a little closer and start going with this. So I will do the usual and go in my trusty Emacs window here, where I'm going to switch to a buffer range that, of course, contains exactly what we have discussed here. So the code you see here at the bottom is exactly what we were talking about earlier, right? So this is my range class, and I don't have much. The only addition is that I made a convenience function range that takes two value of some type vt. So if I make a range over int, that would be int, and that returns such an object. So let's put it to the test by actually writing a test program. So I'm going to create rtest2, and of course we'll do what you're all used to. The first step is to import IOStream, and the second is to include my range class. Right? Once this is done, if I want to avoid unnecessary typing, I'm going to use the namespace std, define my main program, already put the return 0 at the end, and my first step would be to declare a range, and I'm going to make a range, mistyped, sorry, a range of integer, and let's call it my range, and it's going to go from 0 to 10, right? A very straightforward range. Now, once I have that, and notice that I could create it by calling even the range function, right? So this is okay, I can do that, right? Either version is perfectly okay. Once I have done that, I like to be able to loop over this using my trusty iterator, right? That's the whole point. I created these iterators. I'd like to be able to do that without further ado, right? So I'm going to simply say, here, I want to use a range int, and the name of the class is iterator, and it's going to be from. And how do I get it? Well, we know full well how we get it. We use myRange, and we call the begin method. Now, this is supposed to go up to a certain point, right? We keep looping as long as from is different from, well, you know it, myRange.end. And at each iteration, what we're going to do is increment from by 1. Now, once I have this loop, I'm ready to rock and roll and write the code that ties it all together. So here I will use cout and say I is equal to, because this is the counter variable, right? I could even, rather than calling it from, let's call it I. That will be a little neater. Right, beautiful. And now I'm going to say star I and put line feed. That's it. I have my program. Now I can switch to a shell to actually compile it and say C++ rtest2, that's the one we just wrote together, output into rtest2, and we use version 14 of the standard. Compile this, it's done. If I run it, lo and behold, we get exactly the output we were expecting, namely we have a program that's looping from 0 to 9, which is the open range that we have defined between 0 and 10 excluded. So this is doing exactly what we want. But let's take a look at the program again, right? And really appreciate what is going on. So this simple program defines my range, and then I'm saying for I being a range int iterator. Okay, great. So I am indeed using a nested type, the nested type iterator that is inside my range class, and I'm using my range begin and my range end to actually define the boundaries of my interval by actually calling upon the range to manufacture iterators that mean something to me. So this is working exactly as intended. That's great. Now let's see a little bit whether we can make this a little more readable, because let's face it, this is somewhat verbose. And there are several ways to actually improve on the readability. As you know, I can say auto, right? I can say that my iterator is an automatic iterator in that as a type that's automatically inferred. So in this case, when my range begin is called, we know it's going to be, or at least the compiler knows it's going to be an iterator over range, and it's returning the correct thing. Does this work? Well, no surprise, right? You know what's going to happen. This works beautifully well, no issue whatsoever. So it does what we want. So we can already write this. But then I'm still calling my range begin and my range end, and you wonder like, oh God, I mean, this is quite verbose. Can we do any better? And now I'm going to reveal something if you hadn't realized it yet. I talked about it several times already, but a loop like this is no different than writing the loop like this. Auto, I, colon, you guessed it, my range. If I do that, this is exactly the same code. Behind the scene, this will work because a for loop that says for, right? So this syntax that says for type value colon container actually gives rise to an implementation in terms of iterators. What this does is that it calls begin and end on the container to obtain iterators to loop over it, and at each iteration it's going to use the iterator to pick up a value. So this should work just as well and make use of our iterator. Let's verify whether this is the case. I compile. There is something here it doesn't like. Yes, that's normal, right? I forgot to fix one thing. Remember that here I is no longer an iterator, right? Before it was an iterator. Here I is the current value that the iterator is pointing to. So it's not star I, it's just I itself directly. So this is a value in the range. So I just remove the star, redo this, and it compiles. And if we run it, it behaves in exactly the same way. So this is the better way to write the code. Notice that we're still using our iterator. I can even clean up and remove the curly braces because we no longer need them. And if I want to be completely clean, something that I should do, of course, is say that this I is a reference to a value from the container whose type can be figured out automatically, and it's a reference to a constant such thing so that it cannot be modified. So in this way, you get the efficiency of having reference management for getting the values of the container. If you have a vector or a range, here it's a range, so it's a range of numerical type, it's not a big deal. But if you were to write an iterator that works over trees, say, and you'd like to have a tree of space station, and you don't want to copy the space station each time by using this syntax, you would have a constant reference to each value that lives inside the container, so that would be even cleaner. So this is probably the most compact form of the code, of the client code you can write, that makes use of a user-defined iterator over a user-defined iterable object like a range. And all of this came for free. Last test we're going to do to see whether this works, since I've changed the type, compile, run, and of course we get exactly what we want. So mission accomplished. We've been able to actually define a user-defined container. Inside that container, nest a user-defined type, make use of it directly by instantiating the iterator by calling begin and end, and finally use the typical range loop of C++ to automatically leverage that iterator, because we're sticking to the API, and this is a templated loop. It's going to call the begin and end method to obtain an iterator, and then the iterator adopts the convention of STL, that is, it provides the comparison operator, the pre and post increment, as well as the dereference operator, so C++ can automatically generate beautiful code for what we want to do, ending up with this nice user-level program. So that's it for this segment, and next time we're going to look at another form of type encapsulation. See you soon.